Let's kick this video off with adding Swagger to my minimal API setup, so we have a nice UI to interact with. And then I'm ready to dive into exception handling for minimal APIs. So add the NuGet package, then go to the program CS, add the add endpoints API explorer and the add Swagger gen. Then in the conditional of is development, because we only want to see this Swagger on the development environment, then we add the Swagger and the Swagger UI. Running the API then would result in a setup similar as you see on the screen, where we have the name of the API of the implementation project, then the grouped routes that we configured in the last video, and then another route I made in the program CS. Those are all standing together and they're not grouped. Let's fix that. Let's go to the API configuration, the minimal API configuration. And here you see we did that map group. So that gives us that nice get post newsletter subscribers. But then we need to still add the with tags, like that, to also have these grouped in the Swagger UI. A common mistake is that people try to do, including myself, with group name, which is actually intended more for API versioning. Running that will give us a nicer grouped UI. You can of course customize this however you like. You can add descriptions, other metadata, and so on. I did recently make a video about global exception handling, where I demonstrate how to create custom exceptions, safely throw these in our business logic and translate them to an HTTP result. So the consumer of the API receives a nicely formatted exception instead of that stack trace. Unfortunately, we cannot reuse that one, since that was a filter on the MVC controllers. And now we're using minimal APIs, which are not using that MVC dependency. Let's take a look at the business code. I'm in the get newsletter subscribers query handler, which lives in the features project, which does not depend on the ASP.NET Core or ASP.NET Core MVC frameworks. So we can't simply return a bad request. It's not possible. And let's now take a look at how that behaves in the Swagger. It gives a 500 and the stack trace. A stack trace the consumer of the API likely has no interest in. This is really gonna tell me at which line and all that. That's not what we should be exposing. And it's not useful, not relevant to the consumer. But as I mentioned in previous video about exception handling, the .NET APIs have some exception handling in place, so a 500 like this would not crash the entire application. So what can we do about it? There is a exception handling middleware, more like a global one, which would translate that 500 with the stack trace into a nicer problem result. Let's give that a go. That would result in a 500, but a nicer formatted result. I was going to say that this wasn't useful for our scenario, but the Microsoft Docs just proved me wrong. This is that same UseExceptionHandler, and it's just setting the status code, content type, whatever, writing its own response. But then it's doing something very interesting, and it's getting from the context.features the exception handler path feature, and then we can access the error. So let's try that. I made a custom exception, just inheriting from exception, and pass down a exception message. I then throw that custom exception in the business logic, and then in the app program CS, I get the error, similarly as in the documentation, and then see if the conflict exception. And in that case, I return a conflict. So I translate that exception into a HTTP result, and that gives us a nice 409. So that was the global approach, which would be similar as writing our own middleware. So I copied over the code you saw before with that exception handler path feature. I did a try catch. So I created a custom middleware and did a try catch on whatever executes. And when there's an exception, I would which I'm throwing in the business logic, I'd expect the same thing to work and then return a conflict, but this approach does not seem to work. But we can, of course, just do, now that we have the exception, we could say E equals exception, target that. Let's have a look. So that seems to be working. And in the Swagger, I get a 409. Great. So what I actually want to accomplish with that, now that we have the know which exception it is similarly as with that API exception filter. We have a list, a dictionary of validation types, which will invoke the fitting method. That method is then responsible for translating that exception, that specific exception type, for example, the validation exception, or here the not found exception, into a problems details and return a not found object result, which will give us a nicely formatted 404 result. But for my modular setup, I actually have a third approach, which is endpoint filters on the minimal API. Let's first explore that. This looks similar as the middleware as well. We do that try catch, and I'm going to give that another chance. Only the context here is not the HTTP context, it's the invocation context of that endpoint, which allows us to access the parameters passed to this endpoint, which is actually really powerful, because before with the MVC controllers, the request body was a stream, and to read that out, you would impact the performance. But in this case, it seems to be just plainly accessible. So all those people who used to write logger middleware to log all of the HTTP request body data, they had to read out that stream and then pass it on. can now just log it as plain text, and that error seems null. So let's just use the exception and check if that's the conflict exception. If so, return conflict. And let's see what that produces. A nice 409 conflict response. Okay, so I showed you two global middleware approaches, and now for me it makes more sense to put this in the module I'm developing. So that would look like this on the map get. But since this is an extension method on the tbuilder, I think we can just move it to the entire route group. Note you might not be able to then target the specific parameters of that method. But maybe take more of a general approach. Context dot arguments, and maybe you can just stringify those or whatever you want to do. And that seems to be working nicely. I passed this context arguments to the conflict result, because maybe you want to log only when there's a conflict, log the parameters or the request body. So you could then write a log statement, of course, but I'm just going to add them here for the sake of the video, and that would result in, if I do test, and then of course I throw that conflict exception, and then it passes down the request data, which is pretty powerful, I think. Before we had to read out those streams not to access this data, but to access the HTTP request body or response body as well. All there is left to do for me now is to move that over to a separate class, and then I can pass it along. So I created a new class, API Exception Handler, and implemented this interface, which gives me this invoke async with the invocation context and the delegate. So, and then you could just do a switch statement on your custom exceptions, and then let that return just that results dot whatever it needs to result. You should check the parameters. Some can have a dynamic parameter like value. Some you really need to specify variable per variable, and then others just take nothing, like the unauthorized, the forbidden, I think. But you can access the exception message if you want to enrich your result with that information. So that's about all there is to it. So I have that as the endpoint filter on my route group. So that will be applied to all of the routes for this newsletter subscribers component. That was all for this video. If you liked the video, please leave a like and subscribe, because the next video will probably be handling the validation exceptions in a similar fashion, but maybe more globally. Stay tuned. See you in the next video.